Okay, we'll now solve with some of the problems of our fifth module. A problem here it is given. A circular loop conductor lies in a z plane with z is equals to 0 and has a radius of 0.1 meters and a resistance of 5 ohms. Given B, our magnetic field density, that is equals to 0.2 sine 10 raised to 3 t into az Tesla. Then determine the current in the loop. This is the question it is asked, and this is asked for 6 to 4 marks in the exam. This is our loop, where a current loop, it is having the magnetic flux density about B in this direction and radius is of 0.1 meter. To find the current in the loop, let us first calculate what is the EMF in the loop. Then a circular loop, here in this case, Z is going to be 0 plane. B is in the Z direction, which is perpendicular to the loop, as you are going to see in the figure. So B is perpendicular to the circular loop. Hence, the total flux is going to be pi is going to be integration with the surface integration S B dot ds. For cylindrical coordinate system, ds is going to be what? R dr d pi into az. The same thing here going to be using. Then what is our B? It is already given in the equation. That is our 0.2 sine 10 raised to 3 of t. That's what here it is written into az. And then for ds, it is of r dr d pi into az. Then az dot az is going to be 1. Then apply the limit for r and also for the pi. Where is our r? Here it is r, and pi is only at d pi only. Therefore, the integration is simple. 0.2 sine 10 raised to 3 into t. This is a constant. You have to write as it is. Then, if I integration with respect to pi, d pi means here we don't have any factors. So, d pi integration is going to be giving as pi only with a limit 0 to 2 pi. Then about r is going to give as r square by 2 with a limit 0 to 0.1. R is given already about 0.1 meters for that reason. Then as I apply the limit here, then about here you'll be getting as 2 pi, 0.1 square by 2. Then simplify here, then you'll be getting the value as pi 6.283 into 10 raised to minus 3 sine 10 raised to 3 of t. Then pi I can write here as 6.283 sine this 10 raised to minus 3 here 10 raised to minus 3. Here it is not. Sorry. In milliwebers, here it is taken 6.283 sine 10 raised to 3 t milliwebers. Here you will be getting. Then the induced EMF E is going to be given as, that is going to be equals to minus d pi by dt. This is a basic equation. When that is going to be equals to minus d by dt of substitute for this here. With respect to t, you have to integrate differentiate here. The sign integration differentiation is going to be cos. So therefore, I'll be taking as minus 6.283 10 raised to minus 3 of 10 raised to minus 3 into 10 raised to cos 10 raised to 3 t. Just these two factors going off now. Therefore, that is going to be equals to minus 6.283 cos 10 raised to 3 of t volts will be getting. Therefore, what is the current it's going to be in a conductor? I is going to be induced EMF to the resistance. Therefore, I is going to be, we got our EMF value divided by resistance. Resistance is of what? 5 ohms. That you have to substitute here. 5 ohms. Just to divide of this, you'll be getting as I is going to be minus 1.2567 cos 10 raised to 3 t of amperes. This is what the problem. Next, a problem for a lossy dielectric, sigma is given as 5 specimen per Siemens per meter, and F long R is going to be given as 1. The electric field intensity is E is given as 100 sine 10 raised to 10 of t. We have to find what is JC and JD and also the frequency at which both have a equal magnitude. Therefore, the conduction current density, that is JC, is going to be equals to what? We know these equations, that is sigma into E. What is our sigma? 5 into E is given as 100 into 10 raised to 10. Just to multiply here, del as 500 sine 10 raised to 10 t amperes per meter square. Then displacement current density, conduction current density and displacement current density JD is going to be dou D divided by dou T. Dou D is of what? Electric field density is F long times electric field intensity. F long times electric field intensity, that is nothing but F long naught F long R into E. F long naught F long R is a constant values. Only thing differentiate with respect to T for the E. Therefore, you'll be getting as F long naught is of 8.854 into 10 to minus 12. It's you know of this value into 1. Dou by dou T of 100 into sine 10 to 10 of T. Then if I differentiate sine, you'll be getting as cos, and the remaining it up to this it will be same. Then about 100 and sine A theta is going to be A sine theta, right? Based on the 10 to 10 cos 10 to 10 T. Just you multiply here, then you'll be getting as 8.854 cos 10 to 10 T amperes per meter square. Then from 2 current density, the condition for equal magnitude is nothing but JC by magnitude of JC divided to JD is going to be equals to sigma divided by F long times omega, that is going to be equals to 1. Therefore, omega is going to be equals to sigma divided by F long, that is nothing but 5 divided by F long value is F long naught into F long R you have to take. Then substitute here, then you'll be getting as 5.647 into 10 to 11. We know that omega is going to be 2 pi F. We got our omega. We can find out what is the frequency. F is going to be omega by 2 pi. Just you substitute here. Then you'll be getting as 89.877 gigahertz. This is also important. It may ask for 6 or 4 marks in the exam. Next is of this question is many times repeatedly asked. That is, find the frequency at which the conduction current density and displacement current density are equal in the medium with sigma is going to be equals to 2 into 10 to minus 4 mho per meter, and F long R is going to be equals to 81. The ratio of amplitudes, which are two current densities, is given by as 1. So JC by magnitude of JC to magnitude of JD is going to be equal to sigma divided by omega F long, that is going to be equals to 1. Therefore, what is our omega is going to be, we want the frequency here, sigma divided by F long, sigma divided by F long naught into F long R you get. Then substitute for your sigma, it is already given. Then about omega R is also given, just you substitute 2 into 10 to minus 4 divided by F long naught is of 8.854 into 10 to minus 12. And F long R is here, it is given as 81, and you will be getting as 0.2788 into 10 to 6 radians per second. Then about omega is going to, you know that 2 pi F. From here we can calculate a frequency. Frequency is going to be omega by 2 pi. Omega, substitute for omega and also 2 pi. Then you will be getting as 44.372 kilohertz. This is the frequency which the ratio of amplitudes of conduction and displacement current are going to be unity at this frequency level. This is one problem. And the next problem is given electric field intensity is going to be Em sine omega t minus beta z into Az in a free space. Find electric field density, magnetic field density, and magnetic field intensity, and sketch the electric field intensity with the magnetic field intensity at a time is going to be equal to 0. This question is asked for 6 to 8 marks. And this is a given equation written as it is. Then an electric field intensity and electric flux density can be related as, we know this, D is going to be F long times E, that is nothing but F long R not into F long R. For free space, here it is given the free space only. Therefore, F long R is going to be 1. Therefore, D is going to be F long R times E. What is our E is given here? F long naught Em sine omega t minus beta z into Ay coulombs per meter square. Then according to Maxwell's equation, that is del cross E is going to be equals to minus dou B divided by dou T. This is what we know. Just you write for del cross E. The equation is going to be Ax Ay Az dou by dou x, dou by dou y, dou by dou z, Ex Ey Ez. That is going to be equals to minus dou by B divided by dou T. In the given expression, where it is varying? It is varying with respect to y direction. For that reason, Ex and Ez is going to be equals to 0 and Ey is given for us. The same thing here it is written. That is going to be Em sine omega t minus beta z. That is nothing but Em, writing the equation for sine A minus B, that is sine A sine B minus cos A sine B. That's what here it is done. Sine omega t cos beta z minus cos omega t sine beta z. Then only of that part, if I take the expansion of that, then I will be getting as dou Ey divided by dou z into Ax plus dou Ey divided by dou x into Az. That's going to be equals to minus dou B divided by dou t. Also, an electric field is varying with respect to z only, and it is not going to be varying with respect to x and y. Therefore, wherever if I'm it's not varying with respect to x and y, so it will be going off, means this part will be going off. Dou by Ey divided by dou x is going to be equals to 0. Therefore, the remaining part is of only of this part. I can take off that here and I can write here as minus Em dou by dou z of only of this part. I can substitute here sine omega t cos beta z minus cos omega t sine beta z of Ax. It's going to be equals to minus dou by dou b divided by dou t. Then just you differentiate here, then we'll be getting as minus Em sine omega t cos, the differentiation is of sine beta z into beta minus again here sine differentiation is of cos omega t cos beta z of beta, that is Ax, that is going to be equals to minus dou b divided by dt. This is remaining as it is. Then simplifying here, minus of beta Em, here it is written cos term here and this minus term here. Then that is going to be equals to minus dou b divided by. Then about minus minus get cancels. Em beta cos omega t minus beta z. This is cos A minus B equation. For that reason, I can simplify here. Ax is going to be equals to minus dou b divided by dou t. Therefore, or else I can write here as this is minus here already there. If I take minus outside, it is going to be plus here. Okay. Therefore, dou b divided by dou t is going to be minus Em beta cos omega t minus beta z of Ax, which is going to be getting. Then separating variables and integrating with respect to the corresponding variable. Therefore, what I will be getting, I want the b, right? If I integrate, I will be getting of my b only. For that reason, b is going to be equals to minus beta dot Em, here it is changed, and integration cos omega t minus beta z of Ax into dt. That's after integration, what will you be getting? Cos is of sine, and b is going to be equals to minus beta Em divided by omega sine omega t minus beta z into Ax waves per meter square. You will be getting. Then b and h relating is of mu. That's what b is going to be equals to mu times h. Therefore, mu r into h. Mu r is going to be equals to 1 for free space. Therefore, b naught is going to be mu naught into h. Therefore, I can write here as h is going to be equals to b times divided by mu naught. That is nothing but minus beta Em divided by omega mu naught sine omega t minus beta z into Ax, amperes per meter. Equation 1 and 4 is equation 1 is of this given equation, and about equation 4 clears that E and H are mutually perpendicular to each other. Therefore, E and H are going to be mutually perpendicular. This is what's the theory? It is Em sine omega t beta z. Here also you got as minus of beta Em divided by mu naught h mu naught sine. It's a perpendicular mutual perpendicular. We proved that. Then at t is equals to 0, E is going to be, so what you will get? Em sine minus beta z into Ay you will get. If I write this as E is going to be Em sine beta z minus of Ay. Then similarly for H, in the same way, what the equation is taken and it is written like this. Minus is going to be plus, for that reason beta Em divided by omega mu naught sine beta z into Ax. That I can write, this whole part I can write as Hm, that is nothing but sine beta z into Az. Therefore, E and H are perpendicular to each other along the z axis. Therefore, assuming that b and beta and em are positive values only, then the graph what you will be getting, this is how you will be getting up. This is the direction of h, and this is the wave of e. At t is going to pi by beta, and here t is going to 2 pi by beta. This is one problem. Next, a circular cross-section conductor of radius 1.5 millimeters and carries a current of I is going to be 5.5 sine 4 into 10 raised to 10 t 10 raised to minus 6 amperes. Find the amplitude of the displacement current density, that is sigma is going to be 35 mole per meter. If length r is given as 10. To confirm whether the given current is a conduction current or displacement, which one you have to find out? Just calculating the value for sigma divided by omega f long, that is nothing but sigma divided by omega f long naught into r. Then you substitute here 35 divided by 4 into 10 raised to, here it is given, it is omega, 10 raised to minus 10, 10 raised to 10 into f long naught is 8.8442, 8542 into 10 raised to minus 12 into 10. F long r, it is actually f long r actually. Then I will be getting as 9.888, where it is greater than 1, when the ratio sigma to omega f long, it is greater than 1, the given current is conduction current. Therefore, the magnitude of the conduction current is given by JC is going to be conduction current divided by area of cross section. Therefore, conduction current is given as 5.5, already given here, into 10 raised to minus 6 based on here. Then about divided by area of cross section, pi r square. Therefore, r is given as 1.5 milli, then 1.5 into 10 raised to minus 3 whole square. Calculate for this, we'll be getting as 0.77809 amperes per meter square. Then, hence the magnitude of the displacement current density is obtained by using of the relation. Therefore, JC divided by JD, that's going to sigma divided by omega mu. What do we want? What is our displacement current in terms of current density? For that reason, JD is going to be omega by f long divided by sigma into JC. Then substitute for all the values, then we'll bring it as 0.07873 amperes per meter square. Next is of different problems based on different dielectric medium which it is going to fall. Just you remember for which medium, which dielectric medium the signal is placed, based on those velocity equation and propagation constant. The attenuation constant is going to be R0, phase constant equation, intrinsic impedance by wavelength equation. You have to remember the equation, then it will be easy for when we are going for the calculation way. It's not that these will be remain same for all the medium. Velocity and all it will may be, but attenuation constant, phase constant, they may be varying. Some equations will vary, some equations will be as usual. Here a problem it is given. A 300 megahertz uniform plane wave propagates through fresh water, for which sigma is given as 0 and mu r is going to be equals to 1 and f long r is given as 78. What you have to calculate? We have to calculate attenuation constant, phase constant, wavelength, and also about the intrinsic impedance. For the first, because of this water is there, means it is of a perfectly dielectric. Therefore, for given medium, fresh water, the conductivity is going to be 0 only. Therefore, assuming medium to be lossless medium, so we can write that attenuation is going to be 0, that is alpha is going to be equals to 0. The phase constant is given by beta is going to be omega square root of mu f long. That is nothing but I can write here as mu square root of mu naught mu r, f long naught f long r. Then putting substituting for the values of all here. Therefore, what is omega? 2 pi f I can write here. F is given already of 300 megahertz. Therefore, 2 pi f. Then mu naught is of 4 pi into 10 raised to minus 7. It's given. Then mu naught is given as mu r is given as 1, and constant values of mu naught f long naught, substitute that, and for f long r is given as 78. Then just by using calci you can calculate that. You can will be getting beta as 55.529 radians per meter. Then the wavelength is given by lambda is going to be 2 pi by beta. Just to substitute, then we'll be getting as 0.1131 meters. Then about intrinsic impedance, eta is going to be square root of mu divided by f long. Just to substitute for mu naught, mu r, f long naught, f long r value here, then we're getting as intrinsic impedance eta as 42.656 ohms. These are all the question where it is asked for 6 marks or else 4 marks in the question paper. Then one more problem. Calculate the attenuation constant and phase constant. Here we want attenuation constant and phase constant for a uniform plane wave with frequency of 10 gigahertz in polyethylene for which mu is going to be equals to mu naught and f long r is going to be 2.3 and conduction is going to be 256 into 10 to minus 4 mho per meter. For propagation constant, we know that our gamma is going to be equals to alpha plus j beta. And from this, we know that equation square root of j omega mu sigma plus j omega f long. Then for this, you just substitute for omega as 2 pi f omega and mu as mu naught mu r. And for conductivity is given that you can write again omega is going to be 2 pi f. And then about our f long is going to f long not into f long r. Then you substitute for all the values here. Then go on reducing the equation. Then in terms of an angle, you will be getting you just go on reducing the equation. Then you will be getting as gamma is going to be square root of 101.025 into 10 to 3 with an angle of 179.98 degrees. Then that is if I take the square root of that, then it will be getting as 317.84 with the angle 89.99 degrees. If I'm converting from polar to rectangular, we're getting as 0.0554 plus j 317.84. Therefore, from this, if I compare with the equation of this with this, then I can tell that our alpha is going to be 0.0554 Napiers per meter. Then our beta is going to be 317.84 radians per meter. So a problem. And one more problem here it is a lossy dielectric is characterized by f long r is going to be 2.5 and mu r is going to be 4 and conductivity is going to be given as 10 to 3 mho per meter at frequency 10 megahertz. What are all things we have to find out? Attenuation constant, phase constant, velocity propagation, wavelength, and also about the intrinsic impedance. For the lossy dielectric, the propagation constant is going to be remaining. What are the given things? We just write here. Then gamma is going to be square root of j omega mu into sigma plus j omega f long. Then as usual steps, go on substituting for all. Then you'll be getting off your, from that part, you'll be getting attenuation constant and also about the phase constant. When you reduce the equation here, then you'll be getting as gamma is going to be in terms of polar 0.7355 with the angle of 72.14 degree. Then gamma is going to be alpha plus j beta. That is nothing but from this, comparing the real and imaginary part, I will be getting as alpha is going to be 0.2255 Napiers per meter and beta is going to be 0.7 radians per meter. You will be getting off. Then velocity propagation, v is going to be omega by beta, 2 pi f divided by beta. We know the beta value and also we know what is omega. Just you substitute here. Then you will be getting as v is going to be 8.9759 into 10 to 7 meters per second. The wavelength is going to be lambda is going to 2 pi by beta. Just to substitute, then you will be getting as 0.975 meters. Then intrinsic impedance, for which medium we are going for, that is very important. Lossy dielectric, then I can substitute here as j omega mu divided by sigma plus j omega f long. Then go on substituting for each and every values. Then we'll be getting as eta is going to be 429.39 with an angle of 17.86 degrees, 86 degrees ohm. This is about eta. One more problem it is given based on the same with a different medium. In a homogeneous region where mu r is given as 1 and epsilon r is given as 50, the fields are given as E is going to be 20 pi e raised to j omega t minus beta z of az volts per meter, and magnetic flux density is given mu naught hm e raised to j omega t minus beta z of ay Tesla. Find what is omega and what is hm if the wavelength is given as 1.75. It's a homogeneous region. Therefore, assuming that it is of a lossless medium, therefore conduction is going to be 0. The wavelength equation is of what? Lambda is going to be 2 pi by beta. Beta is going to be 2 pi by lambda. Then 2 pi by 1.75 will be getting as 3.59 radians per meter. For lossless medium, beta is going to be, we know this, omega times square root of mu epsilon, that is going to be called 3.59. Therefore, I want what is omega. Omega is going to be 3.59 divided by square root of mu epsilon. Then substitute for each and everything here. Then I can, omega is going to be 1.522 × 10⁸ radians per second. Then magnetic field is going to be, H is going to be given as B divided by F mu naught. That is nothing but Hm e raised to j omega t minus beta z. Then what is our intrinsic impedance? Eta is going to be square root of mu divided by epsilon. Then I'll be getting as eta is going to substitute for the values here, 53.278 ohms. Then intrinsic impedance can also be expressed in terms of magnitudes of electric and magnetic fields. Therefore, eta is going to be what? Based on this, Em by Hm I can write. From the expression, the magnitude of Em is taken as 20 pi based on here. Em, this is what it is of Em based on the standard formula, standard equation I can write. This for Hm is going to be Em by eta, that is nothing but 20 pi divided by 53.278, that is going to be equals to 1.1793 amperes per meter. This is what, how we will be getting the equation for Hm and also for the omega. You should know all the equations, then it will be easy for you. Okay, one more problem. It is similar to the previous one. For that reason, here it is taking. Determine alpha, beta, gamma, voltage, lambda, and also for the intrinsic impedance. That is eta. For damp soil at a frequency of 1 megahertz, given that epsilon r, mu r, and also sigma it's given for us, 12, 1, and 20 milli mole per meter. To test the type of the medium, which medium it is of, just we have what you have to do. We are just going for sigma divided by omega epsilon. Just you substitute here. A frequency is given for us, then 10⁶. Then remaining all is given. Just you substitute 26. You got as 29.96. The it is greater than 1. Therefore, at the frequency, the ratio of this at frequency 1 megahertz is of damp soil acts as a quasi conductor. Therefore, the propagation constant is going to be, gamma is going to be j omega mu of sigma plus j omega epsilon. Then go on substituting for each and every values here, which are already know. Then gamma will be getting as 0.3973 with angle of 45 degrees per meter. Then gamma is going to be alpha plus j beta, that is nothing but in a rectangular form, 0.2809 plus j 0.2809 meters. And comparing on real and imaginary parts, you'll be getting as alpha is going to be 0.28909 Nepers per meter and beta is going to be 0.2809 radians per meter. Then velocity is omega by beta, 2 pi f divided by beta, substitute for all. Then you'll be getting as 22.36 into 10⁶ meters per second. Then wavelength is going to be 2 pi by beta. Okay, just you substitute. Then you'll be getting as 22.368 meters. The units are going to be differing. Keep that in your mind. Then intrinsic impedance is going to be, eta is going to be square root of j omega mu divided by sigma plus j omega f long. Then substitute for all, all the equations. Then eta is going to be given as 19.869 with an angle of 44.05 degrees ohms. This is how a problem is given for us.